Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Chase Whyte, who holds a master's from Georgia Tech in electrical engineering. How are you doing today?
I'm doing well. How are you?
I'm doing good. So, to start off, I wanted to ask what made you choose your major for college?
Um, First of all, it's a slight correction. So I originally got my bachelor's in electrical engineering from the University of Washington. So that was my very first major was originally at University of Colorado Boulder. I originally went there at the time to be with my girlfriend, scholarship money, and then they also do have a really good physics and engineering program. They had a really cool major called engineering physics, where you basically take all the same physics as a physics major, and then also kind of supplement it with engineering classes with a, likely path to graduate school after to maybe specialize in engineering. But, for more personal reasons, because I obviously didn't work out, I ended up moving back to where I'm from, which is Washington, Seattle. So I chose electrical engineering because it is, um, it has actually has the most math of the engineering, and I've always been, a big fan of math, of, puzzles and just, anything that where there's just one right answer. Um, so I chose electrical engineering, and then that's also, the computer science school at UW is very good, but it's also hard to get into. So a lot of people who don't get in will instead choose EE and then major in embedded systems, where you do some, embedded C programming, and then you get into what I'm currently doing right now, which is digital design. So you have classes where you write in a language called, usually it's System Verilog or Verilog. They're basically the same thing, but System Verilog has some added features. And so you work in those classes, you work with FPGAs and ASICs. Uh, well, it was mostly FPGA stuff, but basically for those who don't know what that is, that's basically like the best I can describe it is a customized computer processor. So, computer processors are general purpose, right? Where they can execute a wide variety of instructions, whereas these FPGAs and ASICs are customized to run specific do specific tasks or run specific algorithms a lot faster because they're specialized to do certain things. So that's where I was introduced to my current path, and then so I ended up um, sorry. I'll stop there, and then that's where I got into my job that I'm doing right now. Was after bachelor's.
Uh, yeah. So do you want to just talk about that job then?
Sure. So I got a job at Boeing out of college. It was peak coronavirus. It was in 2020, sometime in like August. So it was almost no one was hiring. So I know I heard from so many people them getting offers rescinded and just a whole ton of rejections. So only very big companies were hiring then. So I got like interviews at like Apple and Nvidia. But those technical interviews I did okay in. Apple and I did terrible in Nvidia was okay. But either way, they didn't go forward with me. And I ended up at Boeing, which is so like I said before, I'm working with FPGAs and ASICs, designing code, writing code in System Verilog. And honestly, I do wish that the job was a little bit more coding, but often what ends up happening is it's, a small part of it is writing the code, and then you do a lot of extra tasks with like writing documentation. It's really important. I know no one likes to write documentation, and I see a lot of really bad documentation from engineers. So that's something that you want to be good with. You want to be organized and be able to write documentation, be able to explain your thought process, explain how your design works. It's a very important skill. Definitely want to develop those soft skills in addition to hard skills. But yeah, so System Verilog is a pretty interesting language in that, when you're writing it, you are like software programming is sequential, right? You execute one line and then the next line and then the next line. Whereas with Verilog and System Verilog, because it's hardware, there's a lot of stuff happening in parallel. So it's sort of a different way of thinking about it, but it's really interesting.
Yeah. So I see you started a master's of computer science at Georgia Tech. Uh,
Exactly, exactly.
what's that like?
So Georgia Tech, they have the It's called the OMSCS program. It's a super well-known program for computer science. I think when I checked when I did it, it was rated like the number two online computer science degree behind Stanford. And there are definitely several reasons why I chose it. So, Boeing does pay for you getting a master's degree. I know some companies do that, and I would definitely recommend people take advantage of that because you have for me, because I got my undergrad in electrical engineering, I feel like I was able to gain more skills and, potentially open more doors in the future. But yeah, their program is one that has a really, fairly low barrier of entry. It's, not super difficult to get into, but it has a very, very high dropout rate because it's still a rigorous and difficult program. So it is, fairly, at least as far as I'm aware, fairly well respected. And I know that's sometimes hard to find with online degrees. A lot of the times they aren't really super well, respected. But yeah, no, it's definitely I was able to learn a lot of interesting stuff, a lot of C and C++ programming, low-level programming, some computer architecture knowledge. And one other really big point about the OMSCS program, like I said, it's low barrier of entry, so like a lot of people could get into it. The price is also extremely low. It's extremely, extremely good. So the price ends up being, so you have to take 10 classes. You can do a max of two classes per semester or one in summer. You can apply to more if you want, but I wouldn't really recommend that. Um, depending on if you're working or not. But yeah, it's really cheap. It ends up being maybe around $6,000 or $7,000 for the whole degree. So it's really really good price.
Yeah. So you're still working at the same place that you're talking about earlier. But do you have any ideas for where your future might hold?
I'm not too sure yet. I am since I just got the master's and Um, Boeing is a great company. It's really good to kind of develop yourself and get, they have lots of training resources and all that good stuff. So, it's a good place to work. The department that I work in is definitely, has a strong ASIC and FPGA department, but I would say that it takes a long time. You're gonna work there for a while and the salary raises aren't super great. It's like kind of a high security, but you aren't gonna be making a ton of money. You're not gonna be making as much money as working at, some of the like, Facebook, Amazon, Google, Apple, all those other companies. So I am just looking around and seeing, what's out there and what the next steps are because I've been here for 4 years and you know I think it's definitely, from what I understand, most people are kind of hopping around every like 4 or so years. You kind of want to change companies, so you can, one for salary raises, two, seeing a different work environment, and yeah, it's definitely usually a good idea to make sure your salary doesn't stagnate and you keep learning.
So if you had to give one piece of advice to someone who's still in high school or early in college, wanting to go down a similar career path as you, what would you say?
Um, I definitely, so in the field of like computer science and then also a little bit in FPGA and ASICs, although I would say that the competition isn't quite as high for FPGAs and ASICs because not as many people really know about them. But you really want to, once you're starting college, you want to, start getting stuff on your resume as much as possible. It's really just not enough to just take classes and even get good grades. It's just not enough anymore. You want to use as many of the resources at your school as possible. You want to go to career fairs, network, maybe develop a relationship with you know, a couple professors that you really like. And then that's going to be really important when you need letters of rec, especially if you want to go to grad school. So that's really important. And then, finding research, finding internships as soon as possible. It isn't always easy to find an internship right away. So, if you can't find an internship, then, there should be clubs at your school, different, groups that you can get involved in, just, any way that you can boost your resume. And then eventually, once you do have the resume, then you can eventually get those internships and eventually get those jobs. And the pipeline for internship to getting a full-time job is probably your best bet if you're wanting to work at, those really top tech companies. Like there's the quant like high frequency trading firms and quant firms. Those are kind of big ones right now, is like, you're making the most possible money there, and probably working with the smartest and best people. Yeah, so like if you want to work in, any of those top 10 companies, the FANG companies, then finding an internship and then, being pipelined into a new graduate job is your best bet. But, doesn't always work that way, sometimes you have to, work your way up, and it's a journey. But as long as you keep learning and keep working hard and keep building up your resume, then eventually you should be fine.
All right then. Thank you for joining me.
Yeah, no problem, Ron.